Okay, so today we're going to look at the basic attributes of our quadratic function. Some of this information you've already seen, some of it's going to be a little new, and so I'm going to use different colors and stuff as we go through. So first, like I said, we've got our quadratic function. Our parent function is f of x equals x squared. So that's simply our basic function, no transformations at all. And if we look up here, our graph for our parent function makes our nice parabola that we're used to with its vertex at 0, 0. So as we add our transformations, all we're going to do is where our f of x is here, we're going to replace that with our x squared. So a f of x, which is our vertical stretch or shrink, is simply going to be a times x squared. F of bx inside the parentheses, whatever transformation's inside the parentheses, we have to put it inside and replace our x with this new piece. So this is going to be parentheses b times x squared. Remember, so this is our vertical stretch or compression, and this is our horizontal stretch or compression. Now our negative outside the f of x is our reflection over our x-axis, and we're simply going to go negative x squared. Our negative x inside the parentheses is our reflection over the y-axis, and we're going to go negative x squared. Our k values are our vertical shift up and our vertical shift down. So since it's outside the parentheses, we're just going to tack it on to the end. Our h's inside the parentheses are our shift left by h, shift right by h. And since it's inside the parentheses, we have to put it inside the x squared, or inside the squared function. So this is going to be x plus h squared, and this is going to be x minus h squared. And then you can just label the effects of those transformations yourself. Now, key to understanding and interpreting our transformations is to look at the vertex form of our function. And all the vertex form is our function where our transformations are applied, but this squared function here is not expanded. So remember, we've got our a that's outside, our b inside, x plus or minus h squared plus or minus k. I need to put a little f of x here. So our vertex form of our function, f of x equals a times parentheses b times parentheses x plus or minus h parentheses parentheses squared plus or minus k. And the reason this is called the vertex form, if we remember, our vertex is negative h comma k. So you can see when it's in this form without the squared function or the squared operation expanded, we can just simply read our function and get our vertex. The standard form is if we expand this squared operation and then simplify. And so this is going to be f of x equals a x squared plus bx plus c. And we'll get into that one later as we go through the unit. And this one gives us other information and allows us to solve for the vertex if we need it that way. As we go forward, you'll see this one more and more frequently than you will the vertex form, but we're going to start out with the vertex form first. Figure this out. Okay, so let's talk about domain and range. And I'm going to kind of shift back and forth, so bear with me. So remember, our domain is our set of all x values. And our range is our set of y values. So inputs, outputs from our function. So if we look up here, and if we were to take our function, I'm going to use my 2 pens. If we were to take our function and flatten it down to the x-axis, there's no limit. Our x values are going to go on forever in both directions. So they're going to go to positive infinity and negative infinity. Therefore, for a quadratic function, an x squared, as long as it's quadratic function, the domain is always going to be negative infinity, comma, infinity. Oops. And our inequality is just simply negative infinity less than x less than infinity. And our set notation is our inequality notation with our brace x bar negative infinity less than x less than infinity brace. Now, our y values, if we were to take our function and collapse it inward to the y-axis, then we're going to walk up from negative infinity towards infinity on our y values. Where do our y values start? They start at 0, and 0 is part of our function. And then they continue upward forever. Therefore, our range for this function is going to be 0 to infinity. And we use the bracket because 0 is part of the range. So our inequality is simply 0 less than or equal to y less than infinity. And our set notation, likewise, is simply y bar 0 less than or equal to y less than infinity brace. And you could also write your inequality here as y is greater than or equal to 0. Either way works for writing your range since we have a value in there. All right, let's talk about our basic functions. So our vertex is going to be our negative hk, which since we look at our parent function, there is no h and there is no k, it's going to be 0, 0. And we can see that's true on our graph. So our vertex, 0, 0. Our axis of symmetry, which I'm actually going to draw on here. So actually, I'm going to draw my vertex on here. So our vertex is here at 0, 0. Our axis of symmetry for a quadratic function is this vertical line that goes through the vertex that allows us to reflect our function across it on top of the other side. So our axis of symmetry, so I'm going to go ahead and write something else right here real quick. So if you want to write down here too, negative h comma k, just to reinforce that. Our axis of symmetry, since it goes through the vertex at the x value, we can say our axis of symmetry is x equals negative h. And in this case,